Hi guys, this is Mrs. Cerna, and today we're going to be talking about domain and range and a couple things that go along with that. To start us off, a domain, when you're talking about a function, it's all the values that are inputs for a function. And so we call these things several things, and that's how you know they belong in your domain. Your domain includes anything that would be an input value, the numbers that you put in to try and work out an answer. When we have x's and y's, your domain is going to include the x values of all the things in your function. And then when you have like a word problem or something like that, your domain includes your independent variable, the one that gets to be controlled by you. We're not going to talk about that so much right now, but just keep it in your head. Inputs, x, and independent variables, these are all the things you're looking for when you're trying to find domain. So where we can find domain when we look at different things, if you have a column, a table of numbers like this, well, your domain is just going to be all the things in the x column. So I've circled that right here. So our domain in this guy is going to be, okay, my domain is going to include, you make a set of curly brackets here, and you go, okay, I've got -6 in my domain. I've got a -3 in my domain, a 0, a 3, and a 6. And then you'd close it with another little curly bracket. This is your domain, are these 5 x values for this function. In this guy over here, when you have a graph for your function, it's going to be how far over on the x-axis all of your points are, because remember, it was your x values for your domain. So you look at this point, it's over at 2, 1. So when we're looking for the domain of this graph, the first one I come to is a 2. That's your x value there. The next point along my x-axis as I go along is this point right here, which is at 3, 4. Its x value is 3, so I'm going to say that 3 is part of my domain. As we move along, this guy up here is the next one over along my x-axis that I get to. It is over at 5, 6. And so its x value is 5, and so 5 is in my domain. This guy is at 7, 5, and so 7 is the x value that goes in the domain. And the last one is at 9, 3, so 9 is in your domain. And then you close it off with another cute little curly bracket. So your domain for this function of dots you see is listed out right here. Okay, so you make your list, you check it twice, and then you move on. So what is range going to be then? Well, range is the opposite. It's all of the outputs of your function. These are the answers you get from working a function, or the stuff that comes out of whatever work you did. So the things we're going to call in our range are the outputs. It'll be the y values on a graph, or when you have an equation with x and y is going to be in your range, and your dependent variable is going to be in your range. All those things will tell you what is the range. How far can this graph go up and down on your y-axis? So here, the same set of problems that we had before, the same table here, let's find its range now. So for its range, we're going to look in your y column, all the outputs. And so here, make my curly bracket. I got -3, I've got -1, I've got a 1, a 3, and a 5. End it off with your other curly bracket. There is your range, all of the outputs, all of the y values for this function. On the graph that we had previously, your range is going to be how high up and down your points can go. I like to start at the bottom so I don't lose track. And so I start with my range and I say, okay, for my range, what's the lowest value on my entire graph? It's right here. and it's at 2, 1. Now remember, range is your y values. And so the height of this low guy here is at 1. So 1 is in my range. Okay, now I'm just going to scoochie on up. The next highest point I have here is actually over to the right. But remember, range is up and down. It's on your y-axis. It's your y values. So this guy at 9, 3, we're looking for how high up and down he is, and he's up at 3. So 3 is in my range. The next highest guy is up here, and his y is at 4. So 4 is in the range. And this guy at 7, 5, 5 is going to be in my range. And then my last one, he's over at 5, 6. His height is up at 6. So 6 is in my range. So my range is 1, 3, 4, 5, 6. That tells me how high up and down along the y-axis my function goes. Okay? And again, I like to do these in order. If you had wanted to go through here with these points and just said, okay, this one is up at 1, this one is up at 4, this one is up at 6, this one is up at 5, and this one is at 3. You could do that, but we prefer them to be in order from smallest to biggest, and so then you might want to rearrange those back into the order I came up with originally. You're going to do what works for you, whatever makes sure you don't miss any points, and you know that it's how high they are when you're looking at the range. Okay? Cleaner off. Let's try one. So on this guy, let's find the domain and range in this table of values, this function. So remember, domain is going to be your x values. And so I take my curly bracket and I'm going to go, 0, 1, 2, 3, 4. And I separate them all with a little comma and close them off with a curly bracket. For your range, I'm going to come to my y values, and oh look, there they are, all nice and tidy. You list them out, 6, 7, 8, 9, and 10. And that's it. That's the domain. That's your inputs. That's your range, your outputs. Okay? Sometimes you'll see it in a sideways table like this. Still, usually the top one is going to be your inputs and your bottom one is going to be your outputs. And so for here, your domain is going to be all these. So 0, 1, 2, 3, 4, 5, and 6. And your range is going to be these outputs on the bottom. So 0, 2, 4, 6, 8, 10, and 12. Okay? So your inputs along the top became your domain, and your ranges along the bottom. Let's try one on a graph. And so you've got this graph of all these random points. Remember, domain is your x values. That's your left to right sideways amounts. So you're going to see how far to the left and right they are. So I'll start at the far left and work my way across so I try not to miss any. So my lowest one here on the left is over here at -4 on the x-axis. This guy right here hits at -4. This guy here hits my axis at -3. Coming over, this guy hits the x-axis at -2. We've got one here, and he's over at -1. This guy's right on the 0. And then over here, this guy's over at 1. See? This guy's over at 2. This guy's over at 3 and 4. So 1, 2, 3, and 4. And they can't go off the screen, you'll live. Are all in my domain. For my range now, I'm going to figure out how far up and down they are. And so this one gets kind of fun. So you go, okay, for my range, what's my lowest? On the y-axis, I find my graph. Well, the lowest is down here, crossing the y-axis at -4. Then my next, there's 2 dots down here, And they're kind of at, what, -3.5 or something like that. And so there's two of them here at this height, at about -3.5, but you only have to write it once in your range. See, you get to be a little bit lazy. Here, I've got these two dots are both at -2 on my y-axis. So I'm going to put my -2. Then going up and up and up. These two values are at the level, they're at about 1/2 or about 0.5 on my y-axis. And then my highest y values are both, see, this one's at 4, this one's at -4. They both have y's that are 4. So I can just write the 4 into my range. Okay? So your domain is how far left and right you go. Your range is how high up and down all of your points are on your graph. Okay? Now, the fun part is these were all discrete functions. Notice how it's spelled. It has an ETE at the end. Not like you care, but it matters. Okay? Discrete functions are a bunch of disconnected dots. D, disconnected dots. And so this would be a dot, this would be a dot, this would be a dot. There might be a lot of them, but they're all disconnected and you can count them, and so you could list out your domain. Or it might look like a bunch of dots on a graph. That's also a discrete function. And so what I've been showing you is discrete ones. When you get to continuous functions, these are connected curves. The curve could be curvy or it could be straight, but if it's connected all together like this, it's a continuous function, and these ones have infinitely many dots all stuck together like this, and you can't write it the way I just showed you. So for this one, you're going to head over to Coach Byerly's video, and he's going to show you how to do these ones. Good luck, y'all.